In this video, we're going to look at further statistics 1 topic in A-level further maths called the hypothesis test of a geometric distribution. So a geometric distribution here is modeled by x follows the geometric distribution of probability P, and we have some formulas here of how we work out the respective probabilities that I would suggest that you would commit to memory in order to be efficient in your examination. So let's take an example of how we would do this. So example 7 here. A company claims that 1 in 8 of their packets of crisps contain a prize ticket. Lee decides to test this claim and he buys a packet of crisps each day until he finds a prize ticket. Lee finds a prize ticket for the first time on the 24th day. Test at the 5% level of significance whether there is any evidence to suggest that the company is overstating the proportion of packets containing a prize ticket. So to distinguish this from the regular binomial distribution that you would have done in regular A-level, the binomial distribution is a constant probability of success. But the way to recognize a geometric distribution, it's the first time when I see that success. So if we go back and read the question, it says, Lee finds the prize ticket for the very first time on the 24th day. So the moment we read that, we know we've got a geometric distribution. Okay, so now the question states, test at the 5% level of significance whether there is any evidence to suggest that the company is overstating the proportion of packets containing the prize ticket. So the first thing we ought to do is to set up a random variable, and we do it the usual way, just like what we do in regular level. Okay, we're going to define a random variable very clearly to the examiner. We say let x be the random variable which represents the number of packets of crisps, or we can say crisps, doesn't matter, packets of crisps opened until a prize ticket is found. So we're going to keep opening up these tickets, or these crisp packets, looking at these tickets until we find the first prize ticket. So because we're looking at the first prize ticket, we know we have a geometric distribution. Okay, so we're going to set up our model. Okay, so we're going to say x follows the geometric distribution. So x follows GEO, and the probability, well, they say in the question, go back to the question, that the probability 1 out of 8, so that's the hypothesized probability of success, or the proportion here. So if the null hypothesis was true, P would remain at 1 over 8. Now go back to the question to see what they're claiming. They're claiming that the company suggests that it's overstating the proportion of the packets of prize tickets. So because they're overstating it, meaning they're overly stating the number of prize tickets obtained. So really, in reality, then if the claim was true, then the proportion would actually be less. So P would be less than an eighth. So what we say here to the examiner is we have something called a one-tail lower test, because it's the lower tail, and alpha in our case would be 0.05. So we've now set up our hypothesis test. Now the key thing here that you need to realize and make clear to your examiner is with the geometric distribution, it has a key property. We say as P it decreases the mean GOP increases. So make that clear to the examiner. And then we state, to test P is less than an eighth, we need to consider the probability that X is greater than or equal to the observed value. Now I say that's very important to make that explicitly clear to the examiner. They can see all your methods of working out. So I always tell my students, make your working out absolutely bulletproof so the examiner can't criticize you. They have to give you full marks. So if we go back to our null hypothesis, well, P is less than 1 over 8. So we want the reverse in terms, because the mean's increasing, we want the reverse for the probability. So it's the probability that X is greater than or equal to the observed value. Well, we're going to go back to the question, what is that observed value? Well, the observed value is the 24th day. So we're going to say, well, we could write it here as well. Say the observed value, according to the question, make it, I will say, write all your information down so it's clear for your examiner what you're doing. So here we've got the probability that X is equal to 24. We can get our calculator from the Casio CT50. And what we're going to do here, we're going to use one of the formulas. So we're going to use that is greater than or equal to. So that's 1 minus P raised to the power of X minus 1. So I'm going to write that down here. 1 minus P to the power of X minus 1. Well, in our case, P is an eighth, so that's 1 minus an eighth, raised to the power of 24 minus 1. So that's going to be 7 over 8, raised to the power of 23. And we can get our value here. So that's going to be 0.0464. 0.0464. And this is known as the p-value. Okay, so I'm just going to write that down here. So we refer to this as the p-value. So we say, since our p-value 0.0464 is strictly less than 0.05, we say we reject H0 at the 5% level of significance. At the 5% level of significance, we say the test is significant. The test is significant. That's why these things are known as significant tests as well. And we say the conclusion, you must write the conclusion. So all of this must be stated clearly for the examiner. You cannot omit anything. All of it must be stated. There is, exactly in this way, there is sufficient evidence to suggest that the company, and we state exactly what they've written, that the company, and it must be verbatim what they've written, the company is overstating the proportion of packets, is overstating the proportion of packets containing the prize tickets, containing a prize tickets. containing a prize ticket. And there we have it. We have our first example. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So the question states, a dice used in a board game is suspected of not giving the number 6 often enough. A player throws the dice and finds that she gets her first 6 on her 20th throw. Does this give significant evidence at the 5% level of significance that the probability of getting a 6 is less than 1/6? So we're going to write down our model and then solve from there. So let's write down our random variable first of all. So we say let x be the random variable that represents the number of throws before getting a 6. So before getting a 6. Right. So now we're going to define our model. So we're going to say x follows the geometric distribution of the probability, which is, if it's hypothesized to be true, that means if the null hypothesis is true, it will be 1/6. And null hypothesis H0 is that P is 1/6. Let's see what the claim is for the alternative hypothesis. That is there significant evidence of, at the 5% level of significance, that the probability of getting a 6 is less than 1/6. So it must be that the proportion or the probability is less than 1/6. We have a one-tail lower test. And alpha is 0.05. And as we did in the example, we did the same thing here. You must state this: as P decreases, the mean of the geometric distribution P increases. So we're interested in the probability of x being greater than or equal to our observed value. Now, our observed value in the question is the 20th row, the 20th throw, sorry. Okay, so it's going to be, I can write here, observed value is 20. Always good to write these things down for the examiner. So greater than or equal to 20. We can use our formulas. You should memorize these formulas, by the way. So we want to be greater than or equal to x, so that's 1 minus p to the power x minus 1. So let's write that down. So that's 1 minus p to the power x minus 1. So in our case, it's 1 minus a sixth, 20 minus 1. So we're going to do the following here. We're going to do 5/6 raised to the power 19. And that's going to give me the following here, which is, we can do this in my calculator, 0.0313 to 4 decimal places. I said to you that this is known as the p-value. So we can say since our p-value, so since 0.0313 is strictly less than 0.05, we do our usual conclusion. So we reject H0 at the 5% level of significance. The test is significant. We have sufficient evidence to suggest that. And now we're going to go back to the claim and write it verbatim. So that the probability of getting a 6 is less than a 6. Okay. That the probability of getting a 6 so it should be a 6. Should say 6 is less than 1 over 6. We're done.